Good morning. So this talk is, are you getting the best out of your MySQL indexes? And I am a DBA. So this talk is basically about why is the optimizer not doing what I think it should be doing? We're kind of assuming you have some indexes and you're like, why isn't it using the indexes I think it should be using? So there's a lot of MySQL quirks around indexing, and like any other thing on a computer, it does exactly what it is told to do and what you tell it to do. So we're going to talk about, or I'm going to talk about, some of these quirks and why it's not going to do what you think it's doing. So first I'm going to talk a little bit about a key versus an index. A key is a key constraint. That's why it's named that. The full name is key constraint. You have like a primary key constraint, a unique key constraint, a foreign key constraint, and then everything else is an index, and as CJ Date would say, that's an implementation detail. He's big on like theory, and he's like, indexes, who cares? That's an implementation detail. So here's the question. What is the plural of index? Indices. Okay, I see a lot of people speak Latin here. Anybody, do you guys like speak all, who cares? It's really just, it's not. I say indexes. If it's good enough for the Library of Congress, it's good enough for me. This is a comic strip. Anyone read Sheldon? My husband bought this for me as a Christmas present one year, and it's like somebody coming to correct it, like, I think you mean it's a database, not a database. And he's like, nope, I just got this one data point right here. Just got the 3. That's it. It's a database. So really, I don't care what you call it. So let's talk a little bit about more jargon. A simple index is an index that has one field in it. So like last name, that's a simple index. A compound or a composite index has more than one field in it, like last name, comma, first name. This is actually kind of interesting because MySQL has prefix indexes. So an index on last name, comma, first name gives you an index on last name, first name, as you'd expect. But it also gives you an index on last name for free. You're already covered. So a lot of people will kind of make both these indexes, and that's redundant. You don't need to do that. Let's talk about data structures. MySQL, pretty much, we're all using InnoDB here. MySQL uses B trees for data and indexes. Usually, you can specify, hash, I think, for InnoDB if you want to. So yeah, you have hash for memory tables. This is what a B tree looks like, and you can see that there are like numbers in it, and they're in a certain order. But like, the number 1 is all the way at the left, right? The smallest values on the left, and the largest values on the right. And so what happens is to find data, you'll go at the top and you'll be like, is it less than 7 or greater than 7? Is it less than 16 or greater than 16? And you kind of work your way down through the tree to find things. This is images from Wikipedia. So B trees are excellent for like one equality match. You want to go find, the number 10. How would you do that? You look at like, well, 10 is greater than 7, less than 16, so we'll go in the middle. And it's between 9 and 12, but it doesn't exist, so we can't match. So like where foo equals 11. A few equality matches, those are also good. Again, where foo in 5, 10, 11, you just kind of go through that process a couple times. Range searches. Oh, range searches are great because you find the beginning of the range and you just kind of scan on through the data till you get there. So like where foo is in between 5 and 16. But how is it done, right? So let's talk about that. Here's a composite index on last name, first name. It's kind of like a dictionary. Everybody, you guys remember using like a paper dictionary? Sure. And it had those little indexes in the corner, so you needed to find something like, I want to look up the word hello. So you'd like kind of go to like the middle, because that's where the H's were, and you'd use the things at the top to go left and right. That's how B trees work with indexes, and that's also how composite indexes work, right? Super easy to find words in a dictionary or last names beginning with G. Really hard to find first names beginning with G, because that would be like, show me all the words where the middle letter is G. Really hard to do in a dictionary. So that's kind of why when you have an index on last name, first name, you kind of get the index on last name free. But if you wanted to have an index on first name as well, you kind of want to put that, without last name, you have to put that by itself. So it's perfectly reasonable to have these two indexes, right? If you had this in your data structure, people would be like, okay, that's good. If you had last name, first name as a composite index and then last name, people would be like, that's redundant. You're doing extra work on your rights that you don't need to do. So more on composite indexes. So let's say you have an index on last name, first name, and middle name. This functions as last name, first name, first name, and last name. So you get all those kind of prefixes for free. Now, what does MySQL use an index for? It uses it for matching a where clause, right? So if you're gonna, I want something where foo is 11. It uses it for filtering, so eliminating rows. which you might say, well, isn't that matching a where clause? But when you're talking about joining two tables, you want to kind of do some row elimination there, right? Perhaps for a join. Resolving minimum and maximum values. If you remember that B tree from the previous slides, if you're looking for where foo equals 0, well, you go to the lowest number. The lowest number is 1. It's not there. It knows it can't match it. Or if it says where foo equals 1, it knows it's the minimum. Like, what's the minimum? The minimum is just go down the left side. What's the maximum? Go down the right side. And also to eliminate the need for sorting, because if you get all your rows and you can use the index to just kind of like, okay, what's the next, if you're sorting by something that's in the index, it doesn't need you to do an extra pass to sort it because it's already in the order you want it in. It also helps with grouping. And we'll talk about group by in a little bit. And then also it uses indexes for everything. So if you have something called a covering index, what that means is MySQL does not need to go down to the data level to get all the information it needs. It just goes to the index, it can get everything it needs, which is pretty cool because if you have spinny disks, you don't have to do so many disk seeks and looking around and stuff like that. So doing less work is better. It means faster things happen. MySQL will ignore indexes. So this is where it's like, so what are the quirks? When does MySQL not use an index? For functions. So if you have something like the date of a timestamp column equals a date, it won't use that. Queries and joins if the fields are not the same. So if you have like a date, like where a date column equals a timestamp column, it can't use an index for it because it can't compare apples and oranges. MySQL will also ignore indexes for too much data. This is a huge one, okay? So let's say you have something like select star from table where foo is in 7, 9, and 12. That's 6 lookups versus walking the 10 node tree in our example. So this is our B tree for our index. And this is our B tree for our underlying data, right? So we said select star, we have to get the whole row. We're going to have to go to the underlying data. So first, we have to look up 7. And then we look it up in the index, and then we go down to the data to find it. Then we have to look up 9, and we have to go down to the data to find it. And then we have to look up 12, and we have to go to the data to find it. And as it turns out, MySQL says, it's just really easier to walk that whole tree than to do it. So how much data is too much data? It's actually about 15 to 25%. And can I be more specific than approximately 15 to 25%? No, I can't. But I can show you how it's calculated. It's calculated from metadata. Yay! I never metadata I didn't like. So metadata is approximate ENODB. My ISOM is accurate for metadata, but nobody uses my ISOM. You shouldn't use it. You should use ENODB. But it is approximate, which means sometimes you get kind of wrong, the optimizer does the wrong thing because it's going on the approximate data it has. So you can do an analyzed table to recalculate your statistics. Here's the thing about analyzed table. It does a few dives into the data. How many dives do you guys think analyzed table does into the data by default? The default is 8 pages. Pages are 16K by default. So you're talking about a 128K sample. Now, if you have like a 2 terabyte table, how accurate do you think your 128K sample is going to be? So you can run analyze table like 100 times. It's not going to really matter, right? So if your approximate metadata is a really small sample, it's not necessarily going to be accurate. It is configurable by variables. There are different variables in 5.5 and 5.7. It's called ENODB stats sample pages in 5.5, ENODB stats transient sample pages in 5.7. These are default Oracle's MySQL variables. They're not Percona or anything like that. Analyze table is also very fast. It does lock, but it locks such a small sample of data that it's okay. But because it's fast and it's doing such few dives, it's not as accurate. Optimized table is a lot slower, but a lot more accurate. But again, it locks the whole table for the duration of rereading it, and it will also rebuild the table and rebuild all the indexes. So this metadata is used for rows read and join calculations. So if you do an explain, and it says, approximate rows read is this many rows, that's where it's getting it from. So even the approximate rows read might be completely off. And then cardinality and selectivity, which we'll talk about, and also average value group sizes, which we'll talk about. So cardinality, I mentioned that in the last slide. To choose an index, the optimizer uses metadata. We just talked about that. Cardinality is the number of elements in a set. So the set, a set in mathematics doesn't have any duplicates, right? So if you have, Fibonacci sequences of 1, 1, 2, 3, the set is really 1, 2, 3. The lower the cardinality, the more duplicates there are. So a yes/no field has a cardinality of 2, even if there's a million rows, because it's either yes or no. And selectivity, which I also mentioned, is the inverse of that. So a higher selectivity is a lower cardinality. To make things less confusing, I'll just talk about cardinality, but if someone's talking about how selective something is, it's the inverse. So a unique field that has 100 rows populated has a cardinality of 100. The higher the cardinality, the more unique something is. With a total number of rows, is it going to use an index? Is it going to use a full table scan? That's kind of where it's going to look at cardinality, right? MySQL optimizes for finding a needle in a haystack. If you want to find the haystack, it's really hard. It's going to be problematic. It might not use an index because it's just going to walk the whole thing. It's going to do a full table scan. So for a composite index, right, you really have to pick the order wisely, right? It's better to eliminate as much as possible as early as possible. So higher cardinality items first are great because they eliminate more and more often, right? Again, if you go to a dictionary and you're looking at all the words that begin with H, right, that's a whole lot better than all the words that are somewhere between H and K. Value group. So what's a value group? So consider the value group of body parts, right? And like we were thinking of a column, if you have like a yes, no something, there's only one value group, it's either yes or no. But consider the value group of body parts. And let's just assume that, for the sake of this discussion, body parts, 10 fingers and 2 eyes, right? So there's 12 different kinds of body parts you have, but if you're talking about fingers, there's 10. If you're talking about eyes, there's 2, left eye, right eye. So the average value group size is 6. Now, if you're an optimizer and you're making decisions based on the average value group size, what are the chances that what I'm looking for is in a certain value group? It is terrible for both fingers and body and eyes, even though that's your body part. So it's not accurate for either of them, but it's the average. What else can you do? So looking for eyes, there's not too much data, right? You might say, we talked about the too much data problem, and it's going to scan it. And you might say, well, there's only 2 values in that group, left eye and right eye. Why would it be scanned? Why would it think it needs to do 20% of the data and thus do a full scan? And this is why, because there might be other value groups in there. The optimizer uses 6, not 2. So that might be one of those like quirky things of why it's not using it. So it might tip that query into the too much data territory. So let's talk about composite indexes and sorting. So let's say you have an index on first name, last name. You can sort it in either ascending or descending order, sort of. Descending is actually ignored until MySQL 8.0, which you might not think is a bad idea, right? Like the theoretical structure of the B tree, does it really matter if you go from the end and go this way or go from the beginning and go that way? And the answer is yes, actually, because rewinding a tape takes more work than fast forwarding, and that's true in B trees as well. It's actually slower to traverse the tree backwards. That may be MySQL's implementation of B trees. I don't know if that works for all B trees. I think the theory of B trees is it shouldn't matter. But in MySQL, it actually is slower to traverse the tree backwards. And when you have that, you can't actually have like the first name be ascending and last name be descending until MySQL 8, which is a long way off. It's kind of beta-ish now. So a query might use an index, but still need an extra pass for sorting or ordering, because if you're kind of filtering based on ascending and then sorting based on descending, right? It might need to do an extra pass for that. Prefix indexing. So this is a different kind of prefix. So when you're using varchar, car, and text, and what this is if let's say you have a long text field, but you want to do some indexing on it. In InnoDB, which is what we're all using, you can only use up to 767 bytes. So beware of your character set, because there are multi-byte character sets. So if you're talking about a 3-byte character set, I think that's like 255. It's around there, 240, something like that. You can use the variable InnoDB large prefix to change it to up to 3K. If you want. If you do that, if you change that, you have to be using InnoDB file per table and the InnoDB file format of Barracuda. But it's actually beneficial to make your index prefix as short as possible. The optimizer won't use an index on, like if you have an index on the first 5 characters of your text field, if you have a query that looks for the first 3 characters, the first 4 characters. There's an article on this if you really want to look at it. It's something I just learned apparently back in April, because that's the date of the blog post. So it benefits you not just because the index is smaller, right, but because it doesn't use the larger index. Group by default, will also order by. will also sort, does that extra work by default, silently, without you saying yes, please. This may add an extra data pass. Now, when I first learned this, I was like, well, of course, how do you group things if you don't sort them, right? MySQL can do it it can do it, yeah. So you might see in your explain output using file sort. And what that is using the file sort algorithm to sort things. It has nothing to do with files, so. It's not necessarily bad, it's writing to a file, it's not. It's just using the file sort algorithm and doing an extra pass to sort the data. So you might be like, why is it doing that? I don't want it ordered, I don't care if it's ordered by anything. You can actually avoid this by writing in order by null. So it's actually pretty good practice whenever you're writing a group by to also write an order by. Always use an explicit order by. And the reason I say this is because you're like, well, what about when I know that I want that sort? Why not just leave it blank? And the answer is it can be a self-documenting query. If you have a query that says group by X without the order by, I have no idea if you meant it to order or not. I have no idea. If you say group by X, order by X, I know for a fact that's what you wanted to do because that's what you wrote. Unless you really don't know what you're doing, but I assume you all know what you're doing. There is a bug that people put in that by default, MySQL shouldn't do extra work by default silently. That was put in 10 years ago and still hasn't been fixed. So try to use order by null. But there is a comment in there that says, relying on the implicit group by sorting in 5.6 is deprecated. To achieve a specific sort order, use an explicit order by. Group by sorting is a MySQL extension that may change in a future release. Theoretically, they kind of like know about the problem and they're like, well, maybe we'll do something about it. So don't depend on it, but for now it's still there. So yeah, the answer is always use an explicit order by for each group by. So null and equality, and we're having some tests now. Which statements return true? Does if null equal null return true? No. Very good, not true. Does if x equal null return true? Like where x is a column? No. Very good. No, it does not return true. For the same reason null equals null isn't true, right? Because if x returns as a value and it's not null, then it wouldn't be true. And if x is null, then because of the first reason. Did you have a question?
Yeah, I'm pretty sure that null equals null. Why is it not true?
Oh, why is null equals null not true? Because null, the question is null even a value, right? So I'm going to talk a little bit more about this, right? Null, there's a special operator for null safe operations. You can say if null is null, or if x is null, or is not null, and then there's a null safe equality operator as well. So this is the null safe equality operator. This may be true if x is null, right? So if you say if null less than equal greater than null, that would return true. So that is the null safe equality operator. Yeah, there's a lot of weird things when you're like, why is this not giving me the results I expected? And a lot of times it's just if you don't, this is my plea, if you don't need a null value, don't use it. And a lot of times MySQL will have to do an extra pass through the data if the field is nullable, just to see if there are any nulls, because null isn't a special is a special item. So if the optimizer sees that you have put something that says if field equals null, it immediately returns false because it knows that will never be true. So why even bother looking? Which is actually pretty cool, right? That it returns it fast. The uncool part is that that's probably not what you meant. You didn't mean to be like if 1 equals 0, which is basically what you just said. It knows that the value will never be true. So use is null, is not null, or the null safe inequality operator. But the thing about the null safe equality operator is that there is no null safe inequality operator. So you have to do not parentheses x null safe equal null. Just try not to use null if you don't have to. Like if 0 or the empty string works, use that. And I know there are times where like 0 is not, like you really want to know, oh, I got no answer as opposed to I got an answer and the answer was the empty string. Like let's say I do a survey and I'm like, hey, how'd you guys like the presentation? And 10 people were like, I loved it, I hated it, whatever. Does that mean only 10 people showed up to my talk? Does that mean that 10 people were the only people listening to the talk? Or does that mean that like literally there were 50 people who were like, meh, whatever, I don't want to answer the survey, right? So the difference between being asked and not giving an answer and not being asked at all, right? So sometimes you want that null as, like that is meaningful, right? That is more meaningful than the empty string or 0 or a negative number or whatever. Null and value groups. Remember we talked about average value groups. Let's say body parts is a nullable group, right? Is a nullable field. Let's say we have 2 eyes, 10 fingers, and 3 null values. Like literally we have left eye, right eye, index finger, left, and then like 3 null values. These are our rows. We have 15 rows. How many value groups are there? And what's the average value group size?
3 and 5.
Do you think there are 3 value groups and 5? So that's 3, so it's 15, so it's divided by 3 groups, and the 3 groups are eyes, fingers, and null. Great. Anyone have any other ideas about how many value groups?
2 and 6.
2 and 6. So you think null isn't a group at all, and so it'd be 6. Okay. Any other ideas?
5 and 3.
5 and 3, yes. Oh, not 3 and 5. You think it's 5 and 3. Okay, so there's 5 value groups because each null is its own value group. Interesting. Guess what, guys? You are all correct. But there's one that's more correct than the rest. It's configurable if need be. So there's a variable called enodb stats method, and again, this is in Oracle's MySQL, so it's also in Percona's MySQL. Nulls equal is the default. And what this is this is a single value group for all nulls, so it's the 3 and 5. So it's 15 values, 3 groups, average value group of 5. Now, here's the thing, it's still not accurate for fingers or eyes. So it's still like a really bad approximation. But what can you do? Like there's only so much you can do as an optimizer, right? There's also nulls unequal, which every null is a different value group, and that is a 5 groups, average value group size of 3. It's better for eyes, but that's just a coincidence, right? But if you knew you had that across the board in your application, you could do that. I think most people's applications are so complex. Like I wish it were configurable by table, right? That would make more sense, or by column. Wouldn't that be great? But I'm glad it's not, because that'd be a lot of variables to keep track of per column. There's also something called nulls ignored, in which the nulls are ignored and there is no value group for any of them, and that would be 2 groups, average value group size of 6. So give yourselves a pat on the back. You came up with all the possible explanations. And honestly, I don't see, unless you have like a really small application on one MySQL instance, I don't see anyone really changing that from the default, unless they, really every single column's cardinality is similar with nulls and whatever. So how do keys and indexes work? So primary and unique keys. What is a primary key? It's a row identifier. It can be simple or composite. It cannot be null. You cannot have a null primary key. The disk order is the primary key order for enodb. That's useful if you're scanning a lot of things, right? You get this automatic sorting. If you're using spinning disks, it's next in the place. What is a unique key? It is also a row identifier. It's not the row identifier, but is a row. It's how you identify a row, right? It's a unique set of values where you could say that refers to that row and that row only. It identifies the row. It also can be simple or composite, and it can be null. Now, you can only have one null value, right, if everything is null. Let's say it's a simple index, right? It's one value is null, yes?
Does nulls unequal affect?
Does nulls unequal affect that? I have no idea. Foreign key constraints. It's a parent-child relationship. Does anyone not know what a foreign key is? Besides the fact that the definition's on there. It's a parent-child relationship. So like a customer is a parent of a row in payments. So payments will have a foreign key to customer ID because you can't have somebody paying for something without them actually being a customer, right? And foreign key, parents, customer ID references customer ID. There's an interesting question of should you even bother to have cascading updates or deletes. Somebody's shaking their head, no. And I'm like, yes, it makes it so much easier for the DBA. If you really want to delete something, delete everything. But then you have to be really, like if you delete a customer, shouldn't you delete all their payments? And the answer is, of course, no for compliance, but you should never really delete the customer anyway. So, but it's just one of those things where you can get into a sticky situation if there's been some data loss, right? If there's been data loss and you have some orphaned records, it gets really hairy for us. Especially when replication breaks because of data loss, and then you're like, how do I get this working again? I'm like, okay, let me insert this piece of data. I'm like, oh, now this piece of data is missing. And I'm like, oh, if they just would have done cascading updates and deletes, I wouldn't have this problem. I have a little thing about surrogate foreign keys versus meaningful foreign keys. Well, what do I mean by that? When you're talking about something like a lookup table scenario, like a status, right? So compare this, right? We've all seen this. Yeah, customer IDs and then a status ID, and then you got like a status table where you look up, okay, status 1 is free, and status 2 is paid, and status 3 is disabled, right? But how much more amazing would your life be if it looked like this instead? Wow. Oh, my God. Right? Where the status table is just those statuses. So the cool part about this, right, there's a trade-off here, right? It takes longer to look up and write these when you're looking it up and inserting, it takes longer because they're bigger things, right? Instead of just an integer 4 bytes or a big int 8 bytes, now you have like text, which is several bytes, and if you're using UTF-8 MP4, right, it's even more bytes because it's 4 bytes per character. But it's faster to read because you don't even need to do a join. I don't know what ORMs these days do, and sometimes you don't have control over what the ORM does, but this is just kind of my little, like, I really like meaningful foreign keys. Plus, when you're a DBA and you're like trying to investigate some data, that you're like, oh, well, you know, the status is 17 and I have no idea what that means, right? But if you're like, oh, the status is, you know, they used to be an admin and now they've been blacklisted, like, oh, now I know why these are the things that are the accounts that are, you know, denial of service attacking us or something, right? Did you have a question?
Should we use foreign keys? Should we not use foreign keys?
Yeah.
What's the latest on?
Should we or should we not use foreign keys at all? So here's the thing. What I would say is use foreign keys, but the database is going to reject stuff that doesn't have their foreign key constraints met. So your application had better be able to deal with the fact that MySQL might reject some of your information. And if the way that you deal with that is first you look up the row, and then if the row doesn't exist, you insert it, and then if it does exist, you just put the row in, why do you bother having the checking at all? Like, I'm kind of on the fence about that because if you do it where you're like, oh, sorry, rejected, and the customer gets, yep, sorry, rejected, then that's totally appropriate. Like, you're just kind of like passing the message along. If you're doing the check and balance ahead of time, I'm kind of like, well, maybe you should have the foreign keys and like test and maybe not production. But pretty much if you're doing all that work anyway, you're probably not going to get bitten by any foreign key stuff. So there's theory and there's practice, and in theory is great, and in practice it is not. So that's my it's complicated, it depends scenario. It's usually just easier to keep the foreign keys in production because you don't want to have your production different from test. Yes. Would there be any implication on translation and localization, right, if you're using a meaningful foreign key? And the answer is absolutely yes, right? And a lot of times, you know, does your status table look like this one at the top, or does it look like status English, or what does it look like in a database, right? So that's a very good point. If you're doing localization, right, it might not even be here. It might be like status 1, and then there's like a lookup JSON somewhere that has that localization. This is definitely very good. It's a very simple example. It may take on less meaning in this era of localization. So the question is, would you still have this status table in the second example? And the answer is yes, because you still have that foreign key. We're assuming that there's a foreign key from the customer table to the status table. It just only ever needs to do that lookup when it's doing an insert or an update, or not a delete, just an insert or an update, right? It doesn't need to do that join when you're trying to get the value. Great. So full text indexes can be on car, varchar, and text types. This is how you write a query. You actually write where match against that. It's in the where clause or the select clause. So if you look at the select clause, you can actually see the relevance number. So MySQL assigns a relevance number to how relevant your search term is to the actual stuff. And you can use both with no extra penalty. If you put the match clause in the where and select clause, it's only going to do it once. It has to be the exact same match clause, so it's not going to try to do it twice. Case sensitivity depends on your collation for your columns. So yeah, there's nothing you can do in the match field to be like, oh, you have to match capital letters. If your collation isn't case sensitive, then it's not sensitive. Also, accent marks and things like that are dependent on collation. So if you don't want A to match A with an accent like grave or something, that's in your collation. You can't have a full text index on a partition table. In a composite full text index, all the fields must have the same character set in collation. So if you have a full text index on like title and author, they have to have the same character set in collation. You can't use percent or underscore, which you might use in a like query. You can't use that there. I mean, you can, but it's going to try to match percent or underscore. Well, who knows what the percent is? Yeah. It's a wild card. Match 0 or more. What's the underscore? Match 1. Good guess. Yeah, it is. It is match 1. Against can only take expressions that are constant, right? So I said match against. So you can't say matched body against author because it has to, in the optimizer, has to resolve to a constant. So you can see match body against like concatenate A, comma B, but not against another field. Full text index silent failures. This is fun. So this is the what do you do if your full text index isn't getting what you want? There's a minimum token size for EnoDB full text search. There is MyISM full text search, but since we can do it in EnoDB, we have no reason to use a MyISM table. No reason to use a MyISM table. The default is 3. The possible values are 0 to 16. So if you're trying to search on a 2-letter word, it is not going to work. And you are not going to know why. Because it doesn't give you any errors. It just says, nope, sorry, no results returned. Same thing with a maximum token size if you're looking for something that's larger than 84 characters by default. You can have 10 to 84 as your max. Max token size usually isn't a big of a deal as the minimum token size. And the minimum token size was a big deal because it used to be 4, and then people started trying to look up like com for like .com or org or something like that, and so they changed it to 3 because 3-letter words are important. N-gram token size. Who knows what an n-gram is? What's a token? What do you think a token is in this? What's another word for token? Word. Very good. There are languages in which you don't know what the word delimiting boundaries are, like Chinese. Those use n-grams. So now you have an n-gram token size. Languages with no word boundaries. The default is 2, but you can change it from 1 to 10. There's also a stop word list built into MySQL just for all the silent failures you want. It has words that you would expect like the and in, but it also has like against. And just like, there's hundreds of words there. There's also a magic stop word, which is any word that appears in more than half your rows. So if you take like my blog and you put that into a full text index, all the text, like MySQL, and you search for MySQL, you're not going to get anything. Magically, it's just be like, no, 0 results returned. And you're like, I have like 600 articles. How do none of them have MySQL in them? And the answer is any word that appears there. This is the stop word. The stop word list is changeable. There is a static file, but you can also set a table with the EnoDB-FT server stop word table. But whenever you change your stop word list, you need to rebuild your full text indexes, which takes time. Yeah. And the way that you rebuild the table is alter table drop index and add index. That is the best way to rebuild the table. You can also do an optimized table, but that rebuilds all the indexes. So the reason I want to talk about full text indexes is that they're really cool. So you use full text indexes in natural language mode, where test will also match things like tests and testing, and the relevance may be a little less, but it's there. It does use the stop word list for that. It's ordered by relevance automatically. So again, you do this query and like magically, you don't even need to be like order by relevance. It's going to give you the most relevant stuff first. So you say select ID matched text field against text to match. You can use quotes for exact phrases, but it doesn't count word breaks. So test me will match test comma me or test dash me or whatever. All the fields in the index must be used. So if you have like a full text index on title and author, you have to match against title and author. So that's one of those cases where the composite index doesn't necessarily give you anything for free. Full text indexes in natural language mode with query expansion. It gives you automatic relevance feedback, which is also called blind query expansion. These are the technical terms. What that means is that if you search for a short phrase like database, what it will do is it will do a second pass through the data to find other words that appear in the same text that has database. So it will also match those words. For example, MySQL Oracle Open Source Tutorial. So it does one search on like database, and then if it's like, oh wow, this word tutorial shows up in a lot of the places database shows up, it's going to search again just on tutorial. So you'll get text that matches tutorial that doesn't even necessarily have database in it. So cool. So it does perform the search twice. So it's only really useful if you have like short phrases, because if you don't want to do long phrases probably have all the words in them. Yes, question.
What's the definition of a lot?
What's the definition of a lot? Good question. I don't know the answer off the top of my head, but I can take that to Chatter.
Okay.
Great. It might be 50%, but not that I'm just making that up. So, full text indexes in Boolean mode. So this gives you, you can use Boolean expressions like plus, minus. So plus is and, minus, it can't appear. Tilde will add a negative relevance, meaning that if it appears, it gets, it's like, oh, I don't really want those, but maybe show it to me anyway, but like lower preference. Whereas less than and greater than change the priority. So yeah, there's like, what's the difference between tilde and less than? Less than is just like less important, whereas tilde is like, no, you get like negative points. Or is implied by no operator. So, there's a comma between things. Star is a wild card, because why not have use star as a wild card as opposed to percent? So here are some examples. If you have plus apple, and then you can group with parentheses. So if you have plus apple and plus greater than turnover or minus strudel, right, that means I want to find a bunch of different apple desserts, but I would rather have apple turnover than apple strudel. But still show me the strudel results. If you did negative, right, it would be like, okay, no strudel results. So rank higher than that. If you do apple star, it'll do apple, apples, applesauce, or applet. And I put that in there because the language in the MySQL manual was super confusing, and it made it sound like it was like phrases as opposed to words that begin with apple. So full text indexes in Boolean mode, it does not follow the 50% stop word rule. So if you put a plus in there, it's gonna, like you do plus MySQL, you will get all the articles of MySQL. It still uses a stop word list though, so you still might want to change that. It does not order by relevance automatically, which seems weird to me, but whatever. And the manual has the relevance calculation, so you can look up how they actually calculate. There's a big formula. I was going to put it in here, and I'm like, nobody really cares. But if you do, there it is. You can actually, in a Boolean search, specify a number, at a number, which is the word distance between all the search terms. So you can say, I want to match a column 1 against these 3 words, but make sure these 3 words are no more than 8 words apart. And sub-expressions with parentheses, which we already saw. I'm not going to talk about spatial indexes because that's really out of scope, and also it's not that cool. Like MySQL's implementation of geographical stuff is not really that cool, in my opinion. Knowing all this, when you're doing an explain, use explain extended equals JSON, and I will talk about that in a tech talk in a couple weeks. We'll talk all about explain and how to use it, but that gives you a lot more information, including the length of the indexes being used and the parts of the indexes that are used. So if you have one of those text queries that uses all, the first 4 characters or whatever, and you see that it's not using that, that's where you can do that. We're going to do explain talk soon. If you're not getting the results that you expect, you pretty much need to check your expectations, right? Why do you expect to do that? Like, you're a human being and MySQL is a computer, right? Like, MySQL has all these quirks. Like, a lot of times it comes to like too much data, and you're like, there's 1 row, how is that too much data? And it's like, well, just with the average value group size and whatever, because it'll be like, oh, expected number of rows like 100, and you're like, there's 2 rows. Come on. And then you do an analyze table, and of course that doesn't work because it does such a small amount of data. Like, it's crazy making. So, or it could legitimately be a bug. And there are times that I'm feeling like, no, really, like it doesn't work. Note what is not on this slide. What is not on this slide is use an index hint. Use a force index. Never use those, ever. Ever, ever, ever. Unless you have a fixed set of data, it is never going to change, right? Because if you're using, so there are these things in MySQL called index hints, or you can force an index. And what that says is, no, really think about using this, or like, no, you have to use this. And that's usually the wrong answer, because MySQL optimizes these things for a reason. So, but unless you know like your group size, your average value group size is never gonna change, right? But the more data you put in it, the more it could change, right? You don't know if you're gonna end up putting like ears and body parts next. You don't know what's gonna happen next week. So pretty much, you can use it and it will help for a time, and then it will stop working, and you're like, why doesn't it work? And of course, it's not going to be like, oh, it doesn't work because I put a force index in, because what's going to happen is your application just gets slow, and you're not going to know why. You're going to be like, oh, it's that query, right? It's hard to find that. So yeah, so that's it. And we have some time for questions, comments, feedback. Yes?
In the full text index, you were mentioning the size of tokens is measured, so there's a minimum token size or length. Are those characters or bytes? And then when it's n-grams, is it phonemes or graphemes, or what are we talking about?
All right. The minimum token size is characters.
Okay.
So whatever the equivalent is in n-grams, would that be phonemes?
I don't know, is that going to depend on the characters that you're talking about? So when you say character, if it's a multi-byte character, then it's 4 bytes. So
Right, no, so it's a character length. So the default when it says 3, it's 3 characters no matter how many bytes those characters are.
got it, perfect, nice.
I think it would be the same.
Yeah, so it would be whatever the equivalent is in n-grams, which I think is phonemes, is that right? Any other questions? Comments, feedback? Thank you.
All right.